Okay, we added the title and we have the scale bar and everything. Yeah, we did have a scale bar, and I could do this background a little bit. So I double click on it and it's right here. And for map frame, it's not map frame, this one. Okay, I could do not group background. Yeah, I could do a little bit white. Click apply. There. So look nicer. We don't want, yeah, we don't want the border or something. It's too white. It catch your eye. So I'm gonna do a little transparent. Alright. Right here, color. I don't want outline color. No outline color. Yes. And a little gray, like this. Too gray. Say no color then. No color is not good. Too white. I would say, oh, not 200%. Their appearance, color properties, yeah. We will do a little lighter gray. Transparency, yeah. Half and half. There. Click apply. There. It's too much, so let's do transparency. A little less. Click apply. Yeah, brighter. Yeah, there. So look nicer. So, alright. Move up a little bit for my kilometers. And I don't want a space between here. There. Now it's really nice, okay? Okay, I'm gonna save it. Alright, so now we had a map, and we will move on to quantitative assessment acreage. The final step in the analysis will calculate the acreage of the flooded areas. This information will allow the team, other government agencies, and insurance firm to make damage assessments. So in the first part of this video, we will change the value of the pixels from meters to feet. The spatial dimension of the pixels has always been, and still it is, in meters. So to calculate acreage, the following details are important. So each cell pixel has a dimension of 30 to 30 meters, or 900 square meters. And acreage is 4,046.68 square meters. And before starting the next calculation, we will ensure that only the land that is flooded, it is still selected. We have to go back here, flooded land cover, and add another new field. So flooded land, isolated land cover, it's this one, and we will add a new field. So we will open attribute table, close this out. Alright, it's working, it's just slow. Go to attribute table. Okay, and then I will move this up, and we will do a field calculator, field view. So now we will do another one, is acreage. So acres float. So for the float, we will do numeric, and it will be 1 decimal point. Click OK and save it. Close it out, and we will do the calculation. So acres, we will do field calculator. So we right click the acres field and we select calculate field and we use the parameter. So for input, isolated land cover, and for the name is acres. And this we will have a count divided by no, we have to times 900 first. So I put a parenthesis. So we will times 900. Oopsies. 900. And then we will divide 4046.68. 4046.68. So this calculation multiplies the value of every pixel by its width of 30 meters and its height of 30 meters. So which determines the amount that land cover in square meters. So 30 times 30, so which you will get 900. That the amount which determines the amount of that land cover in square meters. To convert this area to acres, we must divide by 4046.68 square meters. So, and then we click run. And close the attribute table and clicking X on the top of the table. And now we will save the project and we will complete the table. So now we have both quantitative and qualitative analytical material. We will use this material to write a report of the for the team. So other government So other government agencies and insurance firms will help to make damage assessment. So include maps, charts, and written synopsis. And then we will do deliverable, a map showing infrastructure and health facilities at risk from the storm surge. The storm surge affected more than just the wetlands. A variety of infrastructure elements affect a region economy and people's well-being. So next we will explore the spatial distribution of the infrastructure in this region. We will once again make a new map. So in the catalog pane, so for maps, so we will do is that we will show the current map. Okay, map. So right click. So show current map is right here, and click flooded map. All right. So I just say copy and then paste the map and rename it flooded infrastructure. So I will paste it. So now we have flooded land. Okay, and then I'm gonna rename it. So I'm gonna rename it flooded infrastructure. Okay, and then double click the rename map. I already did. So notice that we can toggle between 3 maps. So 1, 2, and then 3. So it's just slow. But you can see that this 2 map can be upside down. I have a big screen. And then as in any disaster, health facilities and the infrastructure that enables people to access them are critical to evacuation and recovery. So we will turn on places. So now contents. So I double click this one. I'm gonna move it here. So this one is, I'm gonna close this. Go to this one. Flooded infrastructure, and I'm gonna go to view and then open my contents. So that flooded infrastructure. So I'm gonna turn on places, but once I turn on places, I need to move everything on top. If not, I cannot see it. So we will right click on streets and symbology. So streets go move on top as well. So, and I'm gonna go to symbology, unique value, and then we will bring the highways out. So we will open symbology. For symbology, that we will have, we will do unique values. Unique values we will do is the highway type, H1 highway type. So once we have the highway type, we will label them. So let me drag it a little bit so we can see here for everything. So for I, it's interstate. And then we have state. And we have a US highway. And we will change the lines appropriate for color and everything. So, and we will turn on railroads. So now let me change the lines first. The color for interstate, that I'm gonna just go to gallery for interstate, highway, interstate highway. I remember we have interstate highway, highway, highway. Okay, 2D. So I'm gonna just do highway. Okay. There. So, and then go back. And we have a state highway. Highway. And then go back. Last one. It's ugly. I will change it for sure. Okay. So the last one I would just say major road. Yep. Major road. Okay. So go back again, and we're gonna close it out so that we have our roads. It's really busy. I'm not gonna show. Oh, I do want to show this because you can see which road is flooded, which one is not. That could be interesting for people to see. And then we will turn on railroads. So we will find railroads, which is right here. And I'm gonna move on top as well. So our railroads, we will change it into the symbology as railroads. Go to the gallery. Okay, railroads. Okay, railroad. Okay, there. And then I'm gonna close it out. So, and we will have hospitals. Turn on hospitals. And move on top as well. Okay. There are our hospitals. I cannot really see because they are in white color. So I'll just say hospitals. Hospitals. Okay. I like the icon. It's really nice. And then we will turn on churches. Churches. And I do think we do have a churches. I will just type in. So, churches. Don't say we cannot see the churches because they're down below. And this icon we cannot see. Then I will type churches. Church. Alright, place of worship. Okay, there. Wow, that's a lot. Small one then. Okay. And we have a churches and close symbology, and we will save everything. Just save. Okay. Those infrastructure, and we can see a lot of churches near the coastal area is flooded, and we will continue to report by decision by describing the distribution of infrastructure and health facilities that have likely been damaged in the storm, make recommendations as how to prioritize the restoration of the damaged elements. Once the analysis is complete, we must develop a solution to the original problem and present the results in a compelling way to the stakeholders. In this particular situation, the presentation of the various data displays must explain what they show and how they contribute of solving the problem. We have decided that the best way to represent the data is create a crowdsourcing map. A crowdsourcing map is an online editable map that is